Hello, it's David Williams from the Electronic Engineering Technology Department at Okanagan College, and the video today is on clipper circuits. And a clipper circuit is a circuit that either cuts off or clips a part of an AC signal. And diodes are typically used to do this, and you can see in this little circuit here, this is a circuit to prevent a signal from driving these speakers, these headphone speakers, too loudly. And these two diodes here are going to clip off any signal that's above their particular voltage, depending on what kind of diode we're looking at here. And we're going to look at a few examples of how these clipper circuits work. Now here's a simple clipper circuit, and before we get into details, I should note that this circuit, as well as the following ones in this video, are taken from Tony Kupalt's documentation that can be found at the website allaboutscircuits.com. It's a great electronics document, online textbook covering the spectrum of AC and DC electrical circuits, semiconductors, digital circuits, all sorts of really good information. And so these examples are taken straight from that document. So what's happening in this circuit? Well, during the positive half of this cycle, this diode here is going to be reverse biased, which means that no current will be flowing in this circuit. Therefore, there is not going to be any voltage drop across this 1 kilo ohm resistor. So the voltage probes here that are measuring at the top here and at the bottom here are going to measure the full voltage swing. So I'm just drawing it slightly offset if I can here, just so they should be basically the same. I'm just showing it offset a little bit so you can see both of the signals. So that's in the positive half of the input signal. The output signal, which is the one V2 here, is going to be the exact same. So on the negative half of the cycle, this voltage here needs to be about 0.7 volts higher than the voltage on this side in order for this diode to become forward biased, and then the voltage across the diode is not going to change much from that 0.7 volts. And that's not going to happen until our input voltage gets down to about minus 0.7 volts, and then at that point it's going to be a constant 0.7 volts, and then at this point again, when the input's at about minus 0.7 volts, the diodes are going to become reverse biased again, and then the input and the output will follow the input. And we're just going to get this signal repeating over and over and over again. So here again, the diode is forward biased, so it's 0.7 volts across it, and we're going to get this repeating over and over again, and it's basically cut off most of the negative part of the cycle. Now this circuit adds a second diode in the opposite orientation as the first diode. So when one of these diodes is forward biased, the other one's sure to be reverse biased, and then what we'll see is there'll be a period where neither one of them is forward biased. So starting with at the beginning here, where the input voltage, which I've designated here with the red signal, that input voltage there is at 0 volts. So 0 volts applied across this diode and applied across this diode means that both of these diodes are going to be reverse biased. There's no current flowing in either one of them. Now as the voltage starts to increase, once it gets above 0.7 volts, this diode here, the first diode, is going to become forward biased, and therefore it's going to maintain its 0.7 volts approximately. Current will be going through it, and we'll maintain that 0.7 volts until we get to the point where the input signal drops down below 0.7 volts, and now that diode is again reverse biased. No current will be going through it, no current's going through the other one either, so the full voltage from the input, or whatever the input voltage is, will be seen at the output. Now going in the negative direction, this side of the diode needs to be at a higher voltage than this side of the diode, so we need to get down to an input voltage of about minus 0.7 volts before this diode will become forward biased and start conducting. So up until that point, the output will follow the input, and then at about 0.7 volts from the input, the output's going to maintain that 0.7 volts, and then when the input again gets below negative 0.7 volts, the diode will again become reverse biased. No current going through this diode, no current going through this diode, so whatever is at the input is going to be